Hello students, I am Karishma from SolveU and today I am going to discuss the topic of Taylor series for functions of two variables. So students, here we will define Taylor series formulas for function of two variables. Let f of x comma y be a function of two variables x and y. Then the Taylor series is f of x comma y is equal to f of ab plus 1 upon 1 factorial times x minus a into fx of a comma b plus y minus b into fy of a comma b plus 1 upon 2 factorial times x minus a whole square into fxx of a comma b plus twice of x minus a into y minus b fxy of a comma b plus y minus b whole square fyy of a comma b plus 1 upon 3 factorial times x minus a whole cube into fxx of a comma b plus thrice of x minus a whole square into y minus b into fxxy of a comma b plus thrice of x minus a into y minus b whole square into fxyy of a comma b plus y minus b whole cube multiplied by fyy of a comma b plus so on. Here fx of a comma b is first order partial derivative of function f with respect to x at a comma b and fy of a comma b is first order partial derivative of function f with respect to y at a comma b and fxx of a comma b is second order partial derivative of function f at a comma b. fxy of a comma b is firstly, you will differentiate f with respect to x and then you will differentiate fx with respect to y at a comma b. fyy of a comma b is second order partial derivative of function f with respect to y at a comma b. fxxx of a comma b is third order partial derivative of function f with respect to x at a comma b. fxxy of a comma b is here, firstly, you will differentiate f twice with respect to x and then you will differentiate fxx with respect to y at a comma b. fxyy at a comma b is here you will differentiate f with respect to x first, then you will differentiate fx twice with respect to y at a comma b and fyy of a comma b is third order partial derivative of function f with respect to y at point a comma b. So it is the Taylor series expansion of function fx comma y about the point a comma b. So now let's discuss one example related to this concept. Here we need to expand f of x comma y, that is e raised to power xy in Taylor series at 1 comma 1 up to second degree. Here our point a comma b is 1 comma 1. So let's start the solution. Here our function f of x comma y is equal to e raised to power x into y and point a comma b is equal to 1 comma 1. So now here firstly we will evaluate the first order partial derivatives of function f with respect to x and y. So f of x will be equal to e raised to power x into y multiplied by y and simultaneously we will find its value at point 1 comma 1. So fx at point 1 comma 1 is equal to e raised to power 1 into 1, that is e. Now you will find partial derivative of function f with respect to y and that is e raised to power x into y multiplied by x. Now fy at point 1 comma 1 will be equal to e raised to power 1 into 1, that is e. Now we will find second order partial derivatives of our function f and evaluate it at the point 1 comma 1. Now f of x comma x, that is second order partial derivative of our function f with respect to x. So that will be first function e raised to power xy into second function derivative is 0 plus y into e raised to power x into y into y. Clear? So it becomes y square e raised to power x into y Now value of f of xx at point 1 comma 1 will be equal to e. Right? Here when you will substitute 1 comma 1, it becomes 1 into e, that is e. Now find f of xy. Here we will differentiate fx with respect to y. So it becomes first function e raised to power xy into derivative of second, that is y, that will be 1, plus y into derivative of e raised to power xy with respect to y will be e raised to power xy into x. So it becomes e raised to power xy plus yx into e raised to power xy. Clear? So now we will find the value of fxy at point 1 comma 1. So it becomes e plus e, that is equal to twice of e. Clear? Now we will find second order partial derivative of a function f with respect to y, that is f of y comma y. Here you will partially differentiate fy again with respect to y. It becomes first function into derivative of second will be 0 plus second function x into derivative of first will be e raised to power xy into x. So it becomes x square e raised to power xy, that is our f of yy. Now find its value at point 1 comma 1 and it becomes e. Clear? Now we will substitute all these values in the Taylor series expansion. So let's write the expansion, that was f of x comma y is equal to f of a comma b plus 1 upon 1 factorial times x minus a into fx at a comma b plus y minus b times f of y at a comma b bracket close plus 1 upon 2 factorial times x minus a whole square into fxx of at a comma b plus twice of x minus a into y minus b times f of xy at point a comma b plus y minus b whole square f of yy at same point a comma b plus so on. Now after substituting the values, we will get f of x comma y will be equal to f of a comma b. Here a comma b is 1 comma 1. So f of 1 comma 1 will be e raised to power 1, that is e plus 1 upon 1 factorial, that is equal to 1. Bracket starts x minus a, that will become x minus 1 multiplied by fx at 1 comma 1, that is here we have written fx at 1 comma 1 is e plus y minus b, b is also 1 into fy at 1 comma 1, that is again e bracket close. Now 1 upon 2 factorial means 1 upon 2 into x minus 1 whole square multiplied by fxx at 1 comma 1 again e plus twice of x minus 1 into y minus 1 multiplied by f of xy at 1 comma 1, that is 2 into e plus y minus 1 whole square into f of yy at 1 comma 1, that is e plus so on. So this is my Taylor series expansion for the given function. So I hope that all the steps are clear to you, and students, if you want me to discuss more about the same concept, then you can come to our website, that is www.solvio.co.in, and thank you so much for connecting with us.